All right, this video is on multiplying and dividing rational expressions. Multiplying and dividing rational expressions. And we're going to go ahead and start with multiplying. So just a little reminder for you, when you multiply two fractions, if we had something like 2 over x multiplied by y over 5, just to give you a really simple example, you multiply straight across. We would just get 2 over y times 5x. That's all we would get. So we multiply straight across. Now, when we are multiplying rational expressions, it's going to be a little bit different from that because we're going to be dealing with expressions that are pretty complicated. And so we wouldn't want to FOIL everything out and then have to simplify because that would be a living nightmare. So what we do is we kind of simplify first and then we write our answers in like factored form. It just makes it easier. So let's go ahead and write a problem out. We're going to say we have 3x over 5 times 30 over 18x squared. So here's what we do. We simplify first, then we multiply. Okay, I'm going to say step 1. We simplify first. Step 2, multiply across. All right, so remember back to the simplifying assignment, we looked at things on the top and the bottom that could reduce, right? But we only had one fraction at the time, now we have 2. So maybe the 3 and the 5 don't simplify, but maybe the 3 and the 18 do. Maybe the 3 and the 5 don't simplify, but maybe the 5 and the 30 do. Okay, so that's basically what we're going to do is we're going to be simplifying, but it's not just with one fraction. We're going to simplify between both of them and we're going to kind of go across. Okay, so I'm going to start off a little bit easy. I'm going to say, okay, let's, there's no necessarily right way to do it. You can do the 3 and the 18, you could do the 5 and the 30, you could do the 30 and the 18. There's a lot of different ways you can do it, and if you're looking at the numbers, you're probably seeing, oh, there's a couple different ways this could go. So I'm going to go ahead and start with the 5 and the 30. I'm going to say that 5 divided by 5 is 1, and I'm going to say that 30 divided by 5 is 6. Okay, and just because these are notes, I'm going to go ahead and kind of show my work. I'm going to show what I have here. Okay, and then I'm going to say, all right, well now the 18 and the 6, that can reduce. So 6 divided by 6, well that's 1. And 18 divided by 6, well that's 3. Okay, so now I've got 3x over 1 equals 1 over 3x squared. Okay. Well, now I can see that those 3's should cancel. We've got a 3 on the top and a 3 on the bottom, and those should go away. Okay, so now I've got x over 1 and 1 over x squared. Okay. And so now one of the x's on the top should cancel with one of the x's on the bottom and just kind of leave it behind. Okay, so now we've got a 1 over 1 times a 1 over x. So we did all of our simplifying. We did lots of simplifying steps. And then we multiply straight across and we get 1 times 1 is 1 and 1 times x is x. Okay. So some people will do it, you know, you can kind of draw it out like that. Some people can like leave the problem up here just like this and kind of cross things out and write on it, cross things out and write on it, cross things out and write on it, and they can totally tell what they did. But it would be very hard in notes to look at that and kind of see it. All right, example 2. So this was if you were multiplying, these were monomials, monomial over monomial times monomial over monomial. Here we're going to talk about trinomials and binomials and that sort of thing. So if I had x squared minus 3x minus 10 over x squared plus 8x plus 15 times x squared plus 2x minus 15 over x squared plus 9x plus 14. Now we're going to think about those simplifying steps that we had. Okay, so remember our simplifying steps. So we wrote it as numerator over denominator. It was in descending order. We factored it. We reduced our common factors. So this is the step that we're going to do first, and then we're just going to write it in simplified form. Okay, so I have a lot of factoring to do with this, so I'm going to go ahead and do all of that factoring that I've got. So two numbers that multiply to negative 10 but add to negative 3 are negative 5 and 2. So I've got x minus 5, x plus 2. All right, two numbers that multiply to 15 but add to 8, that's 5 and 3. All right, so far we got nothing canceling there. Two numbers that multiply to negative 15 but add to 2. It's 5 and negative 3. X plus 5, x minus 3. Two numbers that multiply to 14 and add to 9. That's 7 and 2. X plus 7, x plus 2. Okay, so just like we did in the last problem, we want to cancel out parentheses that are identical, right? So we're going to reduce things that are in common on the top and the bottom. We're reducing pairs of parentheses on the top and the bottom, and they don't have to be directly on top and the bottom. They could be kind of diagonal. So here's a pair of parentheses that reduce. Here's a pair of parentheses that reduce. X plus 3 and x minus 3 don't reduce. They look similar, but they're not identical. And that's all it reduces. And so now at this point, we just multiply straight across. And instead of actually foiling it out, we don't. We just leave it in factored form. So I'm just going to say that my answer is x minus 5, x minus 3 on the top, x plus 3, x plus 7 on the bottom. I'm finished. Whew, what a fun time that was. Ugh, I'm having a great time over here. Okay. All right, next, we're going to go ahead and do dividing. So dividing is just a little bit trickier than multiplying, but not much. So if we started with the same type of idea, 2 over x, and we did divided by y over 5 this time. There's two different ways that math teachers teach this. Sometimes they say cross multiply, and sometimes they say keep it, change it, flip it. I do not say cross multiply because that is very similar to multiply straight across, and I think that's easy to confuse. So I say keep it, change it, flip it. Keep, change, flip. So we keep the 2 over x, we change it to a multiplication problem, we flip the second fraction, and then we do the same thing, 10 over xy. Okay, so here are the steps. So once you do keep, change, flip, then you can multiply straight across. Because then it is a multiplication problem. All right, so let's go ahead and do example 3. So when we do division problems, the first step is different, and then after that, it's literally exactly the same. So for example 3, we're going to start off and we're going to say, okay, I'm going to have x squared minus 1 over 4x divided by x squared minus 5x plus 4 over x to the third minus 16x. Okay, so when we do division problems, we're going to say, number 1, keep it, change it, flip it. Number 2, simplify. Number 3, multiply across. That's it. So we just added one extra step in the beginning, keep, change, flip. So when I start this problem, I'm going to go, okay, keep it, change it, flip it. All right, and now I'm remembering all my simplifying steps. Okay, so they're all in descending order like they should be. Yep. Now I gotta do my factored form. So this one is difference of squares. X squared minus 1 is difference of squares. So I'm gonna go ahead and write that. So I've got x squared minus 1, x plus 1, x minus 1, 4x. Okay. This one right here is, I can see a GCF. So I have x as the GCF, and then when I take out the x, that leaves me with x squared minus 16. And so I can actually see that this part right here is difference of squares. I'm going to go ahead and scribble this out. I'm going to say, okay, that was difference of squares. So x squared minus 16 is actually x plus 4. X minus 4. Okay. All right, and then for the bottom, we are looking for two things that multiply to 4 but add to negative 5. And the two numbers that do that would be negative 4 and negative 1. So x minus 4, x minus 1. Okay. So now we can reduce GCFs, and I do see GCFs that can reduce. I see an x right here and an x right there. The 4 and the x are multiplied, so I can't take the 4, but I can take the x because it's all alone. Okay, so x and x reduce. Then I can reduce pairs of parentheses. So I have an x minus 4 and an x minus 4, an x minus 1 and an x minus 1. Then everything else that's there is left. Okay, so now I'm going to do my multiplying straight across. So straight across, I have an x plus 1 and an x plus 4 on top. And then on the bottom, I just have a 4. Yep, just have a 4. All right. And this video is long enough, so we will do more examples in class tomorrow.